Hi there. In this video, I'm going to work through the 7.1 through 7.2 practice quiz. And before we get started, just know that there's a lot of different ways you could do these problems, so you might have done it a different way and got the same answer, and that's okay. So in the first one, I'm going to write everything in terms of sine and cosine. So this is going to be 2 times 1 over cosine times sine over cosine. And then this right here, I'm going to replace with cosine squared x. All right. Okay, so, that's cosine squared x. So next thing we can do is just combine this into one fraction. So in the numerator, I have 2 times 1 is 2 times sine x, and then times cosine squared x. And in the denominator, I just have cosine squared, or cosine times cosine, which gives me cosine squared x. So the cosine squared x are going to cancel, and we're just left with 2 sine x. And that would be as simplified as we can get that. So that is our answer. Okay, number 2. Again, we're going to write everything in terms of sine and cosine. So tangent, remember, is sine over cosine. And then in the denominator, we have cosine over sine. And in the other fraction, cosecant is 1 over sine x. And then we're just going to leave that denominator as 1 over sine x. All right, so I'm going to do keep, switch, flip with both of these fractions. So the first fraction is going to turn to sine x over cosine x times, and we'll flip the bottom and make that sine x over cosine x. And then same thing over here, 1 over sine x times the reciprocal, which is sine x over 1. Okay, so these are all going to cancel and we'll just end up with 1 right there. This is going to turn to sine squared x over cosine squared x if we multiply, plus 1. And remember, sine over cosine is tangent, so this is tan squared x plus 1. And then if we use one of our Pythagorean identities, we know that tangent squared x plus 1 is actually equal to secant squared x. And that would be as simplified as that one will get. In number 3, I know we usually turn things into sine and cosine, but for this one, we're actually going to use a Pythagorean identity, which is the case a lot of times when you have the powers of 2. All right, so first of all, tangent squared x we can replace with secant squared x minus 1. So we're going to do 2 plus secant squared x minus 1. And that's just coming from the Pythagorean identity with tangent. Right, so that's where this is coming from. And then in the denominator, we're going to leave that as secant squared x. And then we're going to turn this 1 right here into a common denominator. So I'm going to rewrite this as secant squared x over secant squared x. All right, so now that these have a common denominator, we can make one big fraction. So we've got 2 plus secant squared x minus 1 minus secant squared x, and this is all over secant squared x. So notice when we replaced this tangent with secant squared x minus 1, now this secant squared x and this secant squared x cancel, and 2 minus 1 is just 1, so we've got 1 over secant squared x. And remember, 1 over secant is the same as cosine, So this is equal to cosine squared x. All right, and that is simplified. Okay, let's move on to number 4. So we're going to use those even odd identities to get rid of all these negatives. So that's our first step. So cosine of negative x is the same as cosine x. Tangent of negative x is negative tangent x. And then 1 over cosecant is just sine. So I'm going to turn this into, well, this right here would be negative cosecant x using our even odd identities. But I'm just going to rewrite this as plus negative sine x. This is 1 over cosecant. All right, so now let's rewrite this tangent right here in terms of sine and cosine. And that will turn into sine x over cosine x. And this is still negative here. And then we have plus a negative sine x. All right, so these cosine x's, I can put this over 1. So these are going to cancel out. And then I just have negative sine x plus negative sine x, which gives me negative 2 sine x. And that would be my final answer right there. All right, so those are the simplifying ones. So now we're going to move on to verifying some identities. So at number 5, we got a lot of squared terms here, so chances are we're going to use some Pythagorean identities. And the first thing I'm going to do is actually just change secant squared x into tangent squared x plus 1. And I'm going to keep everything else the same. So this is going to be cosecant squared x. And then we're not going to do anything on the right-hand side, so I'm going to leave that alone. Next, we can distribute this cosecant x into here. So we end up with tan squared x times cosecant squared x plus cosecant squared x. Alrighty, and then we can turn this into sine and cosine. So this is sine squared x over cosine squared x times 1 over sine squared x. Then we'll leave this cosecant squared x alone right here. All right, so notice these sine squared x's will cancel out. And we've just got 1 over cosine squared x plus cosecant squared x. And if you remember, using our reciprocal identities, 1 over cosine is the same as secant. So we got secant squared x plus cosecant squared x, which if you notice, that's what we've got on the right-hand side. So then this right here, we got the left-hand side to equal the right-hand side, so that is verified. Okay, number 6 wants us to do the same thing. And a lot of times when you have a squared term, you're going to want to use a Pythagorean identity. So we're going to turn cotangent squared x into cosecant squared x minus 1. And then that is all over cosecant x. All right, so since in this case we have a fraction, we're going to do a love connection here and split this up. So we're going to make this 2 separate fractions. We got cosecant squared x over cosecant x minus 1 over cosecant x. All right, so you can notice some things cancel here, If you have cosecant squared over cosecant, that is just cosecant x. And then 1 over cosecant using our reciprocal identities is the same as sine x. So again, we got the left-hand side to equal the right-hand side, which is what we want. So this is how you can verify that. All right. 2 more problems here. So these are going to use those sum and difference formulas. And if they just give you one angle right here and you're going to split it up, you can split this up in many, many different ways. So the way that I'm going to do this is not the only way. There are a lot of different ways to get the correct answer. So I'm gonna, just looking at my unit circle, I noticed that I can use 225 degrees and 60 degrees. So those 2 degree measures are on the unit circle, and then that's how I can come up with my 285 degrees. So if that's what I'm going to do, I'm going to use an addition formula for sine. So I'm going to break this up into 225 and 60 degrees, which means I'm going to use that formula, the addition formula for sine. So I'm thinking of this as my x and this as my y. So let's fill the stuff in. It's going to tell me that sine of 225 degrees cosine of 60 degrees plus cosine of 225 degrees and then sine of 60 degrees. Okay, and then if you recall, sine of 225 is actually can be replaced with negative root 2 over 2. Cosine of 60 is just a half. Then we have plus cosine of 225 is also negative root 2 over 2. And sine of 60 is root 3 over 2. All right, so we can multiply these. We get negative root 2 over 4 plus negative root 6 over 4, which already has a common denominator of 4, so in the numerator we just have negative root 2, oops, not plus, should be minus root 6. All right, so that is the exact value of sine 285 degrees. Okay. And then 8 tells us we have to use the difference formula to find the exact value of tangent 135 minus 30. Okay, so if you use your subtraction formula for tangent, that means that when we split this up, we are going to think of this as our x and this as our y. Okay, so let's just kind of start filling stuff in here. This is tangent of 135 degrees minus tangent of 30 degrees. And then that is all over 1 plus tangent of 135 times tangent of 30. Okay. So then we have to think of our unit circle, and this is just some work on the side. So 135 degrees matches up with the point negative root 2 over 2, comma, positive root 2 over 2. So if we wanted to find the tangent of that value, we'd have to do our y over our x. So tangent of 135 is going to equal root 2 over 2 over negative root 2 over 2. So that actually just ends up being negative 1. All right, and then 30 degrees matches up with the point root 3 over 2, 1/2. So tangent of 30 is, again, y over x. So if you do a half over root 3 over 2, I'm going to keep switch flip this. So this is a half times 2 over root 3. These 2's are going to cancel. So we get 1 over root 3. I'm going to run out of room I can see. Let me write this over here. So this is 1 over root 3, which we need to multiply top and bottom by root 3 to rationalize that. So this is root 3 over 3. Okay, so I'm going to need to replace everywhere I see tangent of 135, I'm going to put negative 1. Everywhere I see tangent of 30, I'm going to put root 3 over 3. Okay, so tangent of 135 is negative 1. Tangent of 30 is root 3 over 3. And then this is 1 plus negative 1 times root 3 over 3. Okay, and then I'm going to do some simplifying here. So this negative 1 I'm going to replace with negative 3 over 3, so I have a common denominator. And same in the bottom, this is the same as 3 over 3 minus root 3 over 3. All right, so now that these have a common denominator, we can combine them into single fractions. So in the top I have negative 3 minus root 3 over 3. In the bottom I have 3 minus root 3 over 3. So if you end up with these denominators equaling, you can just cancel them. So I really end up with negative 3 minus root 3 over positive 3 minus root 3. But I still need to rationalize the denominator. So to do that, I need to multiply the top and bottom by the conjugate, which is going to be 3 plus root 3. So that's just the opposite of what we got right here. Okay, so I have to do that in the top and the bottom. All right, so if you FOIL all this out, great. I'm going to kind of do this just by a lot of it in my head. So negative 3 times 3 is negative 9. And then I'd have negative 3 root 3 and another negative 3 root 3, so it should be negative 6 root 3. And then negative root 3 times positive root 3 is just minus 3. In the bottom, you can use a trick. If you multiply a number like this by its complex conjugate, you actually just end up getting this number squared. So 3 squared is 9 minus this number squared. The square root of 3 squared is 3. And if you don't believe me, you can FOIL that out. I promise you'll get that. Okay, last thing we can do is combine like terms. We have negative 12 minus 6 root 3 over 6. And these are all divisible, so we can simplify this down to negative 2 minus 1 root 3. All right, so that would be our answer for the exact value of that tangent. Okay, so let me know if you have any questions. I know these are kind of tricky and they take some time, so I'm happy to help if you are stuck.